every so often we do one of our own development projects, and so we're always looking for a piece of land that's reasonable in cost, and we found one.
Oh,
At
very
702
nice.
Hancock. Okay, 702 Hancock Street, Brooklyn, New York. New passive house. We've just taken the scaffolding down. This is a high performance building envelope, super insulated, airtight, high quality windows, triple glazed, really quiet for the residents. Very healthy building. This building has 4 inches of mineral insulation on top of a rain screen. And then on top of that, we have a zinc facade. We use zinc because it has a little more texture, a little more warmth than an aluminum or another type of metal panel. We're building to a passive house methodology where the entire envelope of the building is insulated, air sealed with air barrier and moisture barriers. So the exterior foundation walls and exterior walls of the building that are exposed are insulated, along with a vapor and air barrier. Under the concrete slab, there's 4 inches of EPS insulation with another vapor barrier. So all these vapor barriers are connected, and so the temperatures are controlled. For passive house, a blower door test is critical, so we don't want any air leakage in the building. We don't want any cold air coming in the winter, or warm air coming in the summer when the air conditioning is on. So on a typical building, an old row house or an old tenement, you might have 20 air changes per hour, ACH. Here on a passive house building, we're looking to have 0.6 or below air changes per hour. So it's not completely airtight, but it's really airtight. If there's a leaky building, all the heat's going to rise faster and then go out towards the leaks and towards the top of the building. And that's what you'll see in an old tenement or row house. So this building is probably 1,000 times tighter than your standard construction from the 1900 to 1970s. We have an energy recovery ventilation system, and it's about 90% energy efficient. And what this unit does, it's continuously providing fresh air to the building, so the occupants have filtered fresh air. We're providing fresh air, and at the same time we're exhausting air through this fan system. And what that does, it's a heat exchanger. So say in the winter, you have the warm air leaving the building, and we have cold air coming in. Now we don't want to bring cold air, freezing cold air into the building. We want to temper that. So through a series of tubes, a heat exchanger, the heat from the air going out is passing through by the air coming in, the freezing temperature, and that's reducing the temperature of the air down to 60 to 70 degrees. And that's conserving the energy. There's no energy loss there because we're not exhausting warm air. The air that we're exhausting is heating the air coming in, so there's a balance. All the heat, all the cooling will be powered by the sun, will be powered by the solar panels. We have a central heating system here, heating cooling system. It's done through a VRF, which is a type of heat pump. The compressors are located on the roof of the building, and then each apartment has its own individual fan unit. And in each, which is located up in the ceiling with a large access door for maintenance. And each apartment is able to control the temperature for heating and cooling in the apartment. Super insulated, super healthy, comfortable building. Thank you.